Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this video, we are talking about the two-phase simplex methods and we learn how does it work. So let's get started.
The big M method is commonly used to solve the linear programming model with the artificial variable. However, it can be challenging to calculate the big M in a large model, and it may lead to computational error. In such case, the two-phase method is recommended. This method involves a two-phase. In phase 1, we aim to minimize the summation of the artificial variable. If the sum of the artificial variable becomes 0 by the end of this phase, this solution is used as the initial basic solution for phase 2. In the next example, we apply the two-phase methods. Let's work through the simplex method step by step using the two-phase method for solving the following problem. We have the 4 decision variable and 2 constraints. We can write the model in the standard form as follows. We add the 2 slack variable x5 and x6. Next, in the two-phase method, we solve the model that minimizes the objective function. W is the summation of the slack variable x5 plus x6, subject to constraint of the original model. Essentially, we are trying to optimize the following model. In the phase 1, you can solve the above model and the original model simultaneously by entering the objective function w for phase 1 and z for original model in the same simplex table as follows. This is the simplex method. In the first table, x5 and x6, which are the basic variable, do not have the 0 coefficient in the row 0. So we do the elementary operation like the big M method to make them 0. Then the table is ready for simplex method by objective function w. Here is the final table in the phase 1. We can use this basic solution in this table for starting the phase 2. You can see that it's difficult to find such solution at once. With this basic feasible solution, we do the phase 2 and then reach the optimal solution for phase 2, which are the optimal solution for original problem. So this is the optimal solution for the original problem, which is x1 and x2 is equal to 0 and x3 and x4 is equal to 50 and the other is 0. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.